Okay, so today we're going over compound and. So remember yesterday we went over compound ors. So remember compound sentences are when you have two complete sentences joined with a conjunction or and. So today we're going to be focusing more on ands, but let's go back and review the ors. So a compound or a solution to a compound or is, so the solution to a compound or is has to work for at least one, but the ands are different. A solution to an and compound sentence, it has to actually work for both inequalities. So those ones can get a little bit trickier. Okay, so let's look at number one. It says graph the solutions for each inequality sentence. Notice that number one is not a compound sentence. And notice number two is not a compound sentence. They're just a single individual inequality. So I just call them regular inequalities. But look at number three. Number three has two inequalities. And when you have two inequalities, that is called a compound sentence. So notice we have all numbers less than or equal to -2 or all numbers greater than or equal to 5. So that's called a compound sentence because there are two sentences. And the fact that they're joined with the conjunction or means that we call that a compound type or inequality. So with number one, going back to number one, we just want all the numbers that are less than 3. So all the numbers less than 3 are just an open circle and every number to the left. Number two, the sentence says all numbers greater than or equal to -4. So you should have a solid dot and all the numbers greater than would be to the right. So hopefully your regular graphing skills are really sharp by now. And then remember with an or, as long as it works for at least one of them. So we're going to put -2 and 5, right? We're going to put 5 and -2 on our number line. And we want all the numbers that are less than or equal to, so solid, less than -2, or all the numbers that are greater than or equal to 5. So that's what your answer for number 3 would look like. But let's look at number 4. Number 4 is a compound sentence because it has two. However, it has an and. So we want all the numbers that are greater than 1 and at the same time are also less than 5. Right? So it has to work for both. So to be a solution to a compound and, it has to work for both. So let's just look at that and for a second and what that means. So let's look at a number. Like let's look at a number 7. And let's plug it into the red equation, right? So is 7 greater than or equal to 1? Yes, that is true. Right, now let's plug in 7 into the blue equation. Is 7 less than or equal to 5? That is false. So the number 7 did not work for both of them. So it's not a solution to this sentence, right? So that's the difference. If you come up here to numbers 1 and 2, if it's an and, it must work for both to be a solution. And the number 7 did not make both of the sentences true. It only made the blue one true. So it is not a solution to the system. So we're only looking for numbers that will work, that are solutions for both. So let's try another number. What about the number 0, right? Let's look at the number 0. And if I plug in 0, so if I go back and color these again so we can talk about them better. If I plug in 0 into the red equation, that would give me, right? That would give me 0 is greater or equal to 1. That is false. It does not work for the red equation. But what if we plug in 0 into the blue equation? Is 0 less than or equal to 5? That is true. So it does work for the blue one, but it doesn't work for the red one. But it's not a solution to this compound sentence because it doesn't work for both. It must work for both. So can you think of some numbers that are both bigger than 1 but at the same time less than 5? Can you visualize where those would be? So let's see. let's pick the number 3. If I plug in number 3 into the first inequality, is 3 greater or equal to 1? True. Let's plug it into the second one. Is 3 less than or equal to 5? True. The number 3 works for both, so 3 is a solution to the compound sentence. So how are we going to figure them out? How are we going to quickly find all the solutions that will work for both? Well, this is the trick. So we want to make a separate number line down here, and we're going to put 1, and we're going to put 5, and we're going to put one of these in color. So we're going to put these in red, and we're going to put all the solutions to n is less than 5 in blue. So all the solutions where the numbers are bigger than 1 are from here forever and ever and ever and ever and ever and ever. And then in blue, all the numbers that are less than or equal to 5 would be from here forever and ever and ever and ever and ever. And I'm going to put this one a little bit further on top. So where they intersect, where they overlap is the solution. So they overlap in between 1 and 5. So that's our solution. So the numbers that work for both are between 1 and 5. So we're going to erase this. And we're just going to write our final answer because we don't want it in color. So we have 1 and 5, and we said all the numbers that are between 1 and 5. All the numbers that are between 1 and 5. And you can actually write your sentence this way. All the numbers that are less than or equal to n, and at the same time less than or equal to 5. That's just a fancy way. These two both mean the same thing. It's just a different way of writing it. Ors don't have any multiple ways. So we'll take 2 days to kind of go over this, but it's where they overlap. So let's try it again. So this one is an and sentence, but this is a special type of and sentence. It's like a between sentence. So all the numbers that are greater than equal to 2, so I could rewrite that. All the numbers that are greater or equal to -3, and, so this is an and sentence, all the numbers that are less than or equal to 2. So this is just a fancy way of writing this, right? So that's just a fancy way of writing that. I know math is so confusing. Híjole, as Grandma Vera would say, right? So we want to find all the numbers that are greater than -3 and less than 2. So if we do it in color for a second, we say all the numbers that are less than, greater than -3 would be from here forever and ever and ever and ever. And then all the numbers that are less than 2 would be from here forever and ever and ever and ever. So we're looking for the numbers that will work for both colors. And the numbers that work for both colors are in between -3 and 2. So we say our answers are in between -3 and 2. So let's erase and fix it to where it just has just the one without the color. So this says all the numbers in between -3 and 2. And it has to be solid. You guys, right? Because of the equal to symbol and the equal to symbol. So it has to be solid. So it's all the numbers that are in between. So that would be your answer. Let's look at the next problem, but blow it up a little bit. Okay, so again, we have two sentences joined with the conjunction and. So we need to find all the numbers that are greater than 3, and at the same time, they must also be less than -6. So that has to work for both to be a solution. So for the and ones, we want to say all the numbers that are 3 and -6, and then maybe up above we'll use the color. So all the numbers that are bigger than 3 are from here on, forever and ever and ever, right? That's the red ones. And then for the blue ones, all the numbers that are less than or equal to -6, that would be solid forever and ever and ever and ever and ever. And we want to know what numbers are both colors. So the numbers that are both colors are in between -3 and 6. So we should have an open circle here and a solid circle here. So why is it solid? Because this is red and this is blue. This is open at red, but it's solid at blue. So this one, I'm going to fix this one and make this a better open circle. So this has to be an open circle at 3, and we said everything in between is where they overlap, right? That's where the colors are both blue and red. So we're looking at where the colors overlap. Okay, now let's solve some compound sentences. Okay, so in numbers 9 and 10, we're solving and graphing. So we're solving, and then we got to graph our answer. So notice we have two sentences joined with the and. So we need to actually solve both of them separately. So we need to undo multiplying by -3 by dividing by -3. And didn't we just reverse? Didn't we just divide by a negative? So don't we have to reverse that inequality? So you always, at all times, you've got to look at your reverse rules. And then on the second inequality is a one step. Don't we have to undo adding 4 by subtracting 4? So you're just solving two separate inequalities. And that's -10, and you have to have the and in your answer. So that's the algebraic answer. And then we're going to graph it. So if it's an and, it has to work for both. So we're seeing what numbers are in both categories. So if we got -10 over here and then -6, make sure you put them in the right order. All the numbers that are less than -6 would be from here on forever and ever and ever and ever and ever. And all the numbers that are greater than or equal to -10 would be here solid forever and ever and ever and ever, and where they overlap is right in the middle. So we say -10 is an equal to, so it's solid, and an open circle at 6 and all the numbers in between. So this is what your final answer would look like. It would be those two answers, and then this is your graphical answers. Remember, this is your graphical answer, and this is your algebraic answer. So these are both your answers. So let's look at number 10. Number 10 is written as a between statement. So we could rewrite this as -9 is less than 2n minus 5, and 2n minus 5 is less than 7. So it's basically two sentences joined with an and. You don't see the word and though, because it's just an implied and. So you have that sentence, and you also have this sentence. So there's just two sentences joined. So you could separate them and then solve each of the sentence separately, but we don't want you to, because that takes a lot of time. So we want you to learn how to solve them simultaneously. So this is how you're going to solve it simultaneously. So some, photo math or whatever, they'll probably break it up and write it as 2, and we don't want you to write it as 2. We want you to work with them simultaneously. So you're basically just solving two inequalities simultaneously. So we want to think of this as the ends. So this is like the end, and this is the end, and inside is like the middle. So we want to get the end by itself. So we have to undo subtracting 5. We have to add 5. So if we add 5 to the middle, we have to add 5 to this side of the inequality and to this other side of the inequality. So we have to add side to the both ends as well. And so that gives me -4 on this end, and then a 2n now in the middle because that's 0, and then a 12 on the right-hand side. Then we're going to undo multiplying by 2 by dividing by 2. And whatever we do to the middle, we got to do, because we're working 2 simultaneously, so we must also divide the left-hand side by -2 and the right end by -2. Oh, not -2, just +2. And because I divided by a positive, I'm not going to reverse. So that gives me -2 n is less than 6. So that's our answer. So that means we want all the numbers that are between -2 and 6. So this is called a between statement. That's how you read it. All the numbers that are between. So all numbers between -2 and 6. And it would have to be open circle, because there's no equal to symbol underneath there. So it would be an open circle. And we're talking about all the numbers that are between. Let's see why that is. If you look at this side, all the numbers that are all the numbers that are greater than 2 would be, negative 2 would be from here on forever and ever and ever. And then if you look at this part, all the numbers that are less than 6 would be from here, open circle, all the numbers less than 6, and aren't they in between 2 and 6, just like we had in the picture, right? So it really is that. Okay. Okay, so again, this is a compound and the and is implied. So you could really write this as negative 7 is less than or equal to 1/3 x minus 4 and, right, and, so it's negative 7, 1/3 x minus 4, and 1/3 x minus 4 is less than or equal to 2, and then you could solve each of these separately. But we don't want you to do that. We don't want you to do that. We need you guys to learn how to solve them simultaneously, right? So what you might do is put a highlighter. So grab a highlighter, maybe put a highlighter on the inequalities because we're just solving two of them simultaneously. And we have to undo the subtract 4, right? And so we're going to add 4, so we have to add 4 to the two ends. And then that's going to leave us negative 3 is less than or equal to 1/3 x in the center, and 2 plus 4 is 6. And then we're going to undo multiplying by 3. Instead of dividing by 3, we're going to multiply by the reciprocal, right? So having those good algebra undo steps. And that gives me negative 9 is less than or equal to x, which is less than or equal to 18. So we want all the numbers that are between negative 9 and 18. And so all the numbers between negative 9 and 18, and because of the equal to symbols, they should be solid, and it's all the stuff in between. So this is called a between statement. You could rewrite it and say negative 9 is less than x, and x is less than or equal to 18. So you could rewrite it, but we want you to leave it as its between statement. But just to show you that if we did all the numbers that were greater than negative 9, wouldn't that be these numbers right here, forever and ever and ever and ever and ever? Aren't all those numbers greater than negative 9? And then all the numbers that are less than or equal to 15 would be from here, forever and ever and ever and ever and ever. And because this is an and, we're looking for what numbers will work for both that are both colors. And wouldn't that be right here is where they overlap? So they overlap in between. It's just that when we do your final answer, so you can grab color if you need to, or maybe on a piece of scratch paper, have color and do the number line and see where they overlap. Because where they overlap is your solution. But we can already tell here because this is a between statement, so we can see that they're going to be between negative 9 and 18. So those are your compound and sentences. We'll be practicing some more of those on the next homework assignment.